In this stage, you are going to solve the question number 8. It's a AdMath book, Cambridge AdMath book, and it's exercise number 16.1. Question number 8. It is written the particle starts from rest. It means that its velocity at the point t equals to 0, velocity is 0 as well. And straight line is moving in the straight line, t seconds of leaving the fixed point to the displacement s meters is given by the expression of the displacement given. They're asking us to find out an expression for the velocity and the acceleration. So to do the velocity expression, we need to differentiate it. First time, one time differentiation gives you the velocity expression, and velocity we can write as a v. So let you differentiate the s, 2 gives us 0, and other part cos 2t gives us minus sine 2t, and coefficient of 2 multiply as a minus 2. So we can write it minus 2 into minus 2 sine 2t. So finally it is 4 sine 2t is the expression for the velocity. Now let me go to the acceleration. Acceleration, actually we needed to differentiate this velocity expression another time. Then we would get from there the acceleration expression. So it is sine, if we differentiate the sine, it gives us cos, and coefficient with 2 we need to multiply, so it is 8 cos 2t, and this is our acceleration expression. So the first part is done, only in 2 lines you can finish it. Then the second question, find the time, it is written here time, when the particle comes to rest. The first question, and another question, its distance from O at this instant. So let me first find out the time from here. For finding the time, particle comes to rest, written here. Rest means v equals to 0, we needed to consider. So the velocity expression, we are going to apply the 0. So the velocity, it is 4 sine twice t. Let me write it, 4 sine twice t equals to 0. So definitely it is sine twice t equals to 0. And we know then twice t equals to actually 0, starts from 0, pi, twice pi. So it is given there t equals to 0, definitely first value, the second value is pi by 2, and third value is pi only. But we are going to take the first two value, starts from rest, it started from rest. Then the first time it comes to rest, I mean we needed to consider t equals to pi by 2. First time it comes to rest at the point of pi by 2, and this is our answer of this question. First time rest, second time rest we are not considering, and it starts from the 0 we would not considering for this case. Then the second question is distance from O at this instant. So how to do that? We already have the expression for s. So we already have the expression s, so we are going to put, this is the first question is a, sorry for that. This is the question number b. In this expression we have to put the value t equals to pi by 2. This displacement then converted to the distance. So let you find it out from here. So when uh, t equals to 2, then your expression is 2 cos 2 into pi by 2. That is the expression. So 2 minus 2 cos pi, and actually 2, sorry, it is minus 2. Write it that it is minus 2 into minus 1, because we know that cos pi equals to minus 1. You can use calculator in radian mode, then definitely you would get cos pi equals to minus 1. So we are going to put this value here, so it becomes 2 plus 2, which is 4 meter. So this is our answer of the first question. Because might you have a question, what the value of t equals to 0? T equals to, if we put here t equals to 0, definitely it gives you cos 0 equals to 1, 2 minus 2 is 0, displacement is 0. So second time displacement is actually the distance, because it's turning at the point pi by 2, so we can find out directly, and this is our answer of this question. Hope guys you understood the question. We are going to move the question number 9 now. 9 is a expression is given of the displacement expression is given here. and s equals to is the exponential function, full question. And fixed point 2, from a fixed point 2 it started, it means that at the t equals to 0, that time displacement is 0 as well. Then the first question, find the time when particle is instantaneously at rest. I told in my previous video, instantaneously at rest means velocity equals to 0. So we first have to find out the velocity expression by doing the displacement as a differentiation. Let you do it. This is velocity actually ds by dt. We're going to differentiate, which is 50. In front of it we needed to write. Then exponential differentiation gives us the exponential same thing. Coefficient of t just we need to write in front of it, e minus twice t. And another part, coefficient of minus 4, which is plus 4 e to the power minus 4t. This is our velocity expression. In this velocity expression, find the time they wrote here. So velocity we need to consider v equals to 0 because it is at rest. So if I consider velocity equals to rest, v equals to rest, we can find out the velocity from here. Let me write the expression 15 to minus 2 e to the power minus twice t, then plus 4 e to the power minus 4t equals to 0. Then from there you can write directly 4 e to the power minus 4t equals to 2 e to the power minus twice t. That is the expression. Now you can write it 4 by 2 equals to 4 by 2 equals to e to the power minus twice t divided by e to the power minus 4t. So this is actually e to the power 4t minus twice t, because if you take it up is over there, then the value equals to 2 we got, then e to the power 2t equals to 2. So twice t equals to ln 2 we can write, twice t equals to ln 2, then t equals to half ln 2. This is our answer in exact. Find an expression. Is the question is find the time. This second you can write. If you want, you can write in the point. Let you see the what the point value is here. So press half. Half we can write here half, or 0.5 is the same. Half. Then ln 2. Right there, ln 2. Ln double time pressing. Just the double time. Sorry for that. Ln 2, and it gives us 0.347 0.347 0.347 meter. Sorry, time is second you can write. This is our answer of this question, or you can leave your answer here as exact. The second question in this stage, it is written here, find the displacement of the particle at O. In this question we are going to find out the displacement. We have done the A, particle from O when t equals to 2. From O means when t equals to 0, and it is the displacement is 0. So directly we needed to put the value in our equation for the displacement. So when t equals to, let me write, when t equals to 2, our displacement is, we just need to put the value of t instead of in our equation of the displacement, 15 to e to the power minus 4 minus e to the power minus 4 to the 8, 4 to the 8. So let's see what the value comes out from there. We can do that by using our calculator. Get to do it. It's having with the 50, then bracket e to the power minus 40, shift e, this is the e, uh, shift e here long, then it is shift e, which is minus 4. Then we have to write here negative shift e to the power again minus 8, minus 8. Let's press here. So equals to, we got from a 0.899, 0.899. This is our displacement at the point t equals to 2. Now the last question, it is written here, find the total distance traveled during the first 2 seconds of its motion. Okay, To do this question, actually it's not the direct answer or the displacement distance. We need to check where the displacement becomes zero. At the time velocity is zero, we got the velocity from here, which is e to the power twice t equals to 2, or t equals to 0.34 seconds. So we need to find out the displacement at this stage, at this time. What is the displacement? So let we do it at at time. This is the question number C we are doing right now. At time t equals to 0.347 second, or we also can use e to the power twice t equals to 2. I supposed to write better. It is, if I can write, it is e to the power twice t equals to 2. If we can replace this one in our expression on the displacement, then we will get the value. So directly displacement at this stage, so it is actually 50, and we're going to write e to the power twice t, we're going to write as a 2. So we can write it e to the power twice t as a 2. So this is having with the 2 to the power minus 1, and another value 2 to the power e to the power twice t is 2, 2 to the power minus 2. So let me see what is the value comes out. 50 into half minus 1 by 4, half minus 1 by 4, which is 50 into 1 by 4, 1 by 4, and it gives us the value 12.5, 12.5 meters. So see, this is the maximum from 0 to 2 seconds. The question is 10 to 0 to 2 seconds, what is the displacement? So now we can conclude our answer for the displacement from 0 to 2 seconds. Total distance traveled during the first 2 seconds of the motion. This is we are going to show total distance. You can write here total distance. The first from 0 to, at the moment it is velocity becoming 0, that the value displacement we got 12.5. Let you write here 12.5. Then plus we needed to add the value from 12.5 till to the gap 8.99. So what is the value comes out? Let me see, 12.5, and it is the value 0. Minus 0.899. So this is the total distance. It crosses up into seconds. So we can use the calculator now. Let's see, 12.5, so which is 12, sorry, 12.5 into 2, into 2 can write, this is the double of this length, minus 0.899, minus 0, 0, sorry, minus 0.899. So 0.899, this is, it gives us 24.101. So in 3 seconds we can write 24.01 meter, 24.011, or oh, sorry, 24.101. So in 3 significant it is 24.1 meter. This is our answer of this question. Actually I'm going to explain it from, say t equals to 0, it is here, then it moves to till to here. This is the point where is the t equals to this stage 0.347, 0.347, and that distance we got from here to there, which is 12.5, and that is come back to close to the point, to the stage of, this is the point, say t equals to at the point 2, and the distance it is we got from there, which is 0.899. This is the distance 0.899. That's why total distance it cover from t0 to 2 seconds. So this is the distance we are going to, red color I'm marking, this distance we are having with here. So second one is 12.5 minus 0.899, and previous one 12.5. So addition of these two value is the answer of this question. Hope guys you understood the question we have done from here. So next question is question number 10 and 11. Two questions are remaining. So to see that two questions, you have to click on my next video to watch that 10 and 12. Thanks for watching.